Dear students, how are you all? Well, today we'll start a whole new chapter. This is chapter 13. This is called Modern Physics and Electronics. Well, the chapter is all about modernism of physics part, and the best part is called electronics. Nowadays, we can't go without electronic devices like mobile, tab, iPad, iPhone, so on, and all of these like laptops, all of things are made of electronics. So you might understood how important are all those. To understand modern physics, we should first understand the radiation. First, understand radioactivity. We all know there is a nucleus in the center of the atom, and there are protons and neutrons in the nucleus. The number of revolving electrons around the nucleus is equal to the number of the proton in it. The ratio of the nucleus is about 1 lakh times smaller than the radius of atom, but the actual mass of the atom is the mass of the nucleus even though the size is small. Because the mass of the electrons is 1800 times less than that of the proton or neutron, a proton is positively charged, so the nucleus cannot be formed only with protons, because the protons will be thrown off due to strong repulsion force. So there is a chargeless neutron with proton in the nucleus, and nuclei becomes stable due to very strong nuclear force between neutron and proton. Though there is only one proton in the center of the normal hydrogen atom, there are also hydrogen nuclei with one or two nucleus. With the increase of the number of protons to keep the nucleus stable, the number of neutrons is also increased. But when the proton number exceeds 82, the nucleus starts to become unstable. The nuclear number or proton number, if exceed 82, then the nucleus become unstable. This unstable nucleus try to become stable to emitting a kind of radiation. We call the proceedings radioactivity. This is the definition of radioactivity. Okay, the radiation that comes out from the nucleus is called radioactive ray. So you might understood the definition of radiation and radioactive rays. It is not that when proton number exceeds 82, atomic number more than 82, only then the nuclei become radioactive. Any nucleus of those atoms may be radioactive too. We have classified atoms on the basis of their electron number, which is equal to the number of protons. External property, nature, chemical property, every features and an element depends on the classification of electrons. So the number of neutrons of an atom can be different even the number of electron and proton is equal. This type of elements with different number of neutron are called isotope of the element. So an isotope of an element may be stable, but another isotope of the element may be unstable or radioactive. For example, we can say that element carbon is whose nucleus there are 6 proton, and their carbon isotopes are C12, 6 proton and 6 neutron. C13, 6 protons and 7 neutrons. C14, 6 protons and 8 neutrons. Among those 3 isotope, C14 is unstable, or we can say radioactive. Okay? In 1896, Henry Becquerel discovered the existence of radioactive rays from uranium for the first time. Later on, Rutherford, Pierre Curie and Marie Curie and other scientists discovered radioactivity of their elements. Since radioactivity is not influenced by the external pressure, heat, electric or magnetic field and cannot be controlled, it is accepted as a nuclear phenomenon. Due to radioactivity, radioactive ray emerge and their change of structure of the nucleus and turns into different elements. There is also observed. Okay? So now we will discuss about types of radioactive rays. First, alpha ray. Alpha ray or alpha particle is actually a helium nucleus. A helium nucleus consists of 2 protons and 2 neutrons. So it is charged particles. So its path mentioned can be influenced by electric and magnetic field. When the alpha particle emits from nucleus, it possesses some a mega electron volt or energy. So when it passes through air and collided with the molecules of atom, it can ionize them intensively. Okay? In air, the path of motion of an alpha particle is straight. Since an alpha particle is a helium nucleus, it cannot travel far through the air. It loses its energy by ionizing air molecules, atoms and traveling approximate 6 cm through air before stopping. 6 cm air. Okay? Before stopping. An alpha particle can be stopped by using a sheet of paper. It creates photophosphorylation on zinc sulfide screen. An alpha particle creates many free electrons by ionizing molecular atom in air. It in the path of motion in precise can be detected, or its energy can be measured easily by controlling their free electrons. When an alpha particle came out from a large radioactive nucleus, then the nucleus atomic number will reduce by 2 and its nucleus number will be reduced by 4. Become an alpha particle consists of 2 proton and 2 neutron. Okay, there's an example of it. There's a uranium and this 238. When an alpha particle emits from here, this becomes thorium. Okay? The atomic number of uranium is 92 and thorium is 90. Okay? So it becomes another particle, what I have told you. quite ago. Okay, it is notable that number of electrons of an atom is not considerable. Radioactive nuclei or atom can easily given up receiving extra electron on the form of surroundings. There is a significant figure. It here. Paper, aluminium, and the lead. The alpha ray can penetrate the paper, but beta ray can penetrate with the paper but can't penetrate the aluminium. See, to 5 me. But the gamma ray can penetrate both those, but it can't penetrate the lead wall. Okay. Now beta ray. A beta particle is actually an electron. It is of course a matter of wonder what a nucleus is consists of neutrons and protons only. So how does an electron come out from a nucleus? For that inside of the nucleus a neutron has a diffusive into a proton and an electron. So a neutron is diffusive, a proton and electron, and this is antineutrino. This is a chargeless neutron in converting into positive charge proton and negative charge electrons, so that the total amount of charge remains unchanged. In this right side of the equation, see, this is a particle of a neutrino, antineutrino, a mysterious particle in the world of physics, which is chargeless and its mass is very small. When the alpha particle is emitted from the nucleus, it comes out with different amount of energy, but in case of the beta particle, it is not true. The energy of beta particle depends on the part and total energy radiation received by the antineutrino. Since a beta particle is negatively charged electron, it can be influenced by the electric and magnetic field. When it passes through matter, it can ionize the molecular atom of the matter due to the collision of them. Since the size of beta particle is much smaller than the alpha particle, the cerium nucleus, its penetrate capacity is more than the alpha particle and it can penetrate deep into the matter. It is possible to stop a normal beta particle by a few millimeter thick aluminum sheet, as I told you in the figure. When radiation of beta particle occurs, a proton is incident in the nucleus by decreasing the neutrons, so the number of nucleus remains the same. As the atomic number depends on the number of protons, the atomic number of the nucleus increases, and hence a different nucleus of a different element is formed. For example, radioactive C14, which I've told you beginning, C14 is converted into nitrogen due to the beta decay, like that. C14 is converted N14 and electron plus a antineutrino. Antineutrino. And interesting matter is that only one of the emission of the electrons is beta radiation from the inside of the nucleus. The emission of an alpha antiparticle of electron positron is also called beta radiation. For the reason the proton has to be converted into the neutron inside the nucleus, like that. A proton can be converted inside a nucleus neutrino. The reaction cannot take place outside the nucleus. This is because the mass of the neutron is more than the mass of a proton. In this process, the number of protons decreases by one, hence the atomic number of those decrease by one, and the nucleus of different element is formed. Those neutrinos or antineutrinos are emitted during the beta radiation. They are not considered to be radioactive ray. This is because they are chargeless and they are so inert that even a few light years thick lead sheet cannot stop a neutrino particle. Okay. Then gamma ray. A gamma ray is actually an electromagnetic wave. It has no charge, but as it is strong, its wavelength is very low, frequency is very high. Regardless of the energy of the gamma ray, its velocity is equal to that of the light. When a nucleus becomes excited by radiation of alpha or beta particle, then that extra energy comes out as gamma ray and the nucleus de-excites. A gamma ray is chargeless and massless, so the atomic number of neutron number of a nucleus doesn't change due to the radiation. Since gamma ray doesn't have any charge, so it cannot be influenced by an electromagnetic field because it is chargeless. It cannot directly ionize atom of molecules, but the electrons can ionize atom and molecule in different process, and for that we can understand the presence of gamma ray. To stop gamma ray with energy equal to the alpha and beta particle, a thick layer of lead or several centimeters is needed, like 3 to 5 centimeters. Okay, 3 to 5 centimeter thick lead is needed to stop. Okay, that's all for today. I guess you might understood that the proceedings of chapter 13, and we have discussed about radioactivity. Okay, then after radioactivity we will discuss other scenario of modern physics. Okay, if you have any problem understanding this issue, you will tell me about it. Okay, till then, be good, be safe, see you again. Allah Hafiz.